Hello there! This is a video I've created as a resource for parents who are curious or wanting to learn more about the math concepts and practices done in 5th grade. Welcome to this edition of Math Facts and Practice with me, Miss Louie. Today I'm going to be going over multiplication using the rectangular model, or also more commonly known as the area model. Using the area model for multiplication is not a new concept for 5th grade students. It was previously used in 4th grade to develop fluency and understanding in the multiplication of multi-digit numbers. This will continue to be the case in 5th grade, but with further extension. 4th grade focused on the multiplication of one-digit whole numbers by a whole number of up to 4 digits, as well as the multiplication of two two-digit numbers. In 5th grade, we're going to take this one step further and extend our skills with multi-digit multiplication to explore 3-digit by 2-digit multiplication. Let's begin with the setup of our model. The way our model is set up depends on the multi-digit numbers we're multiplying. Let's use this example right here. 324 multiplied by 15. Remember, we're tying in our understanding of place value in this model, so it will be reflected in our work. We're going to start out with the first number, 324. As we can see, this number has 3 digits and 3 place values. We are going to reflect this in our model by drawing 3 columns, as so. We are then going to decompose our number so that it is represented by place value above each column. 300 plus 20 plus 4. We can clearly see the hundreds place, the tens place, and the ones place. Awesome! Now to do this with our next number. Just like we did with 324, we're going to deconstruct our second number and represent it in our model. However, this time, since we are working with our second model, we're going to represent it using rows. 15 has 2 digits, so we'll create 2 rows to represent it and write our values on the side as follows. As you can see, it'll be 10 plus 5. And there we go. Everything is set up now. Now to the actual multiplication process. We have our area model set up with our values clearly stated. So now we can multiply our numbers. Let's start from left to right. You're more than welcome to start on the right, but I prefer to start on the left and progress this way when using this model. Let's go ahead and start with our hundreds place. Let's take 300 and multiply it by 10. This will give us an answer of 3,000. Let's go to our tens place and multiply 20 by 10, which will give us an answer of 200. And then to our ones place, where we multiply 4 by 10, which will give us 40. Let's go ahead and move back to our hundreds place, but with the second row. So let's multiply 300 by 5, which will give us an answer of 1,500. Then to our tens place, 20 multiplied by 5 equals 100. And then to the ones place, 4 multiplied by 5 equals 20. And there we go. We have all of our products. Now that we have finished our multiplication, we're going to take all of the products we see here and add them together. So in a sense, we are reconstructing our deconstructed equation. Make sure, as you're rewriting all of the products, that you correctly line up the place values. This will ensure more accuracy and ease when adding. Let's start with our ones place. As we can see, there are 0 ones, so our answer is going to be 0 in that column, in that place value. There are 4 tens and 2 tens. Add that together, we get 6 tens. There are 500s, 200s, and 100s. Add that together, we have 800. We see that there are 3,000s and 1,000. Add that together and we get 4,000. And there you go. There is our final answer, 4,860. Let's rewrite this with our original equation. 324 multiplied by 15 equals 4,860. And there we go. That's how you use the area model for multiplication with 3-digit and 2-digit numbers. Just another cool tip about the area model for some extension. It's very important to use the area model in developing understanding of place value because it ties into the method of standard algorithm. The area model becomes the bridge to understanding for students because it makes use of partial products, as we can see here. For comparison, here's what the work would look like for standard algorithm. As you can see, the partial products for the equation are the same in both methods. So as students solidify that basic understanding of place value, the hope is that they'll be able to transfer that knowledge from the area model to standard algorithm.